Okay, so here we go with question number 8. Now, we took a shortcut and put this equation in our graphing calculator, and we determined what the ellipse looked like, and we're able to find the major axis and the minor axis based on the graph. What we did not get was the full equation of the ellipse. And the reason is the work that's required here is complete the square. This is a little bit more involved. That's why we created this video. So I take this equation and I look, and some of these are in terms of x, some of these are in terms of y, and then we have a constant by itself. So I just want to separate those things out. So we've got 4x squared plus 8x, and we've got 3y squared plus 12y, and then of course we've got our constant plus 4 equals 0. When I look at 4x squared plus 8x, I'm going to need to do complete the square on this. But in order to do complete the square, the first thing I want to do is deal with this 4. So I want to factor out a 4 from both of these terms. So I'm dividing them by 4, and I get 4 times x squared plus 2x. Now I'm going to do the same thing to the y term. So I'm going to factor out the 3. I'm going to get 3 times the quantity y squared plus 4y. And then, of course, on that same line, I still have my plus 4 equals 0. So the idea is when we do complete the square, what I want to make is a perfect square trinomial. So I divide my term, my variable term, which in this case is x, by 2. 2 over 2 is 1. So I put x plus 1 quantity squared inside parentheses. And I still have that 4 in front. Now, if I was to expand this out, it would be 4x squared plus 4x plus 4. Because this 4 would multiply by the 1. So by writing x plus 1 squared, what I'm really doing is adding 4 to this equation. So in order to compensate for that, right here, I'm going to put minus 4. Now, for the y term, it's the same thing. I'm going to divide 4y by 2 and get 2. So inside parentheses, I have y plus 2 quantity squared, but we still have the 3 in front. So 3 times y plus 2 quantity squared. Now, if I multiply y plus 2 times y plus 2, I get y squared plus 4y plus 4. And I have that 3 in front. So 3 times the 4 would be 12. So by writing this expression, I'm trying to add 12 to this equation. So I have to do a negative 12 to compensate for that. And then at the end, I've got plus 4 equals 0. Now, we want to put these terms together. So I'm just going to bring down this 4 times the quantity x plus 1 squared. I'm going to bring down this 3 times the quantity y plus 2 squared, right? But then negative 4, negative 12 is negative 16, plus 4 is actually negative 12. So I've got minus 12 equals 0. So if I add 12 to both sides, I get equals 12. Now notice that this looks almost like the equation of an ellipse. We've got our x plus 1 quantity squared. We've got our y plus 2 quantity squared. Those are values we expected to have. The thing we have to keep in mind is the equation of an ellipse is always equal to 1. So that 12 has got to go. So I'm dividing that by 12. If I divide that by 12, I divide everything by 12. Because the rule is the only thing the equation of ellipse can be equal to is 1. So here, we're just going to simplify these fractions. The x plus 1 squared is going to stay, but 4 over 12 simplifies to 1 over 3. So that's over 3. 3 over 12 simplifies to 1 over 4. So that's 4. Then we're equal to 1. And this is how we use complete the square to determine the equation for the ellipse.